All right, in part two, we are going to take a look at a few more things with angles and how they relate to circles. So, the first idea is coterminal angles. Now, we mentioned this idea in part one. Okay, a coterminal angle or coterminal angles are just angles that end in the same spot. Now, an angle can have infinitely many coterminal angles. So let's take a look at an example. Let's say that this is my first angle right here, just like a little maybe 60-degree angle. Well, let's say I want to take another angle. Let's say I start in standard position and go all the way around and then end up here at the same spot. That would be a coterminal angle, okay? That would just be my same angle plus another full rotation. Now, if we're talking about in terms of radians, that would just be my original angle plus 2 pi radians. If we're talking about degrees, that would be my original angle plus 360. Now, we could do the same thing a bunch of times, right? I could say I'm starting in standard position and then I'm going to go once around, twice around, three times around, and end up back here, okay? That's why we say there an angle can have infinitely many coterminal angles because I could just continue rotating and then end up in that same spot. Now, we can also think about going backwards, right? For example, if I say, well, this is my original angle, but then I want to go in the negative direction, I could end up in that same spot. That would be another example of a coterminal angle. So in our little formulas here, when we're saying, well, I could just add a full rotation, add plus 2 pi, or subtract, I'm sorry, I could also subtract, right? Instead of, let's say that this is a 60-degree angle, right? Let's put some numbers on it. I could say this is 60. So if I go the opposite direction, I could say, well, 60 minus 360 would get me that this angle of negative 300 degrees is also a coterminal angle. Right? I could, subtract another 360 degrees. So in our formulas here, we say that n is any integer. So an integer can be positive or negative, right? Okay, so I'm either adding or subtracting a full rotation to get an angle that ends in the same spot. So let's take a look at a few numerical examples. Okay, let's find an angle between 0 and 2 pi that is coterminal with the given angle. Okay, well, all we want to think about if we have a positive angle is subtracting 2 pi until we get to a value that's in between 0 and 2 pi. And we can just do that on the calculator, right? So we don't even have to include the pi. We could just think about 19 over 4 minus 2. And we just want to keep doing that until we get a value that's in between 0 and 2. So if I subtract two rotations, I get 0.75. So to write these, though, we always want to write them as a fraction. So for the answer here, I would say that 3 pi over 4 is a coterminal angle with 19 pi over 4 that is in between 0 and 2 pi. If I have a negative angle, I would just want to add 2 pi until I get to a value that's in between 0 and 2 pi. So again, we can use the calculator for that. Right? I can say negative 23 over 6 plus 2, and then just keep adding 2 until I get to a value that's in between 0 and 2 pi. Again, we want that in terms of a fraction. So I'm going to use math frac or math 1 on the calculator to turn that into a fraction. So in this example, I would say that pi over 6, 1 pi over 6, is an angle between 0 and 2 pi that is coterminal with negative 23 pi over 6. Similar idea for degrees, right? I would just want to say, well, to find a coterminal angle, I just want to start subtracting full rotations, which means 360, until I get an angle that's in between 0 and 360. So if I just start subtracting 360, I find that 120 degrees is the first time I get in between 0 and 360. So here, my answer would be 120. And then for negative 1,330, again, for a negative angle, we would want to add 360 until we get to a value between 0 and 360. So just start adding 360, and we finally see that 110 would be my answer here. Okay, so 110 degrees would be coterminal with negative 1,330 degrees. All right. Our next idea is complementary and supplementary, right? Vocab ideas that I know you've seen before, but just to revisit them very quickly, two positive angles are complements if they add to 90, or in terms of radians, that would be pi over 2. And two positive angles are supplements if they add to 180 degrees, or again, in terms of radians, if they add to pi. So real quick, let's find some complements and supplements of given angles. So for 67, right, if I want another angle that adds to 90 with 67, I could just take 90 minus 67 to get that the complement would be 23 degrees. To get the supplement, I could just take 180 minus 67 and get that the supplement would be 113 degrees. Okay. In my next example, 111, well, to get the complement, I would take 90 minus 111, but that's going to give me a negative value. That's going to be negative 21 degrees. We said in our definition that these angles have to be positive. What that means is that there is no complement for 111. Okay? 111 does not have a complementary angle. It does have a supplement though. 180 minus 111 would be 69 degrees. All right. Now let's do a few in terms of radians. Okay. To find the complement, right, if I want them to add to pi over 2, I would just take pi over 2 minus my given angle. So pi over 2 minus pi over 4. And again, to think about this in terms of fractions, it might be easier to just ignore the pi's and think about this as 1/2 minus 1/4. Okay. We can get common denominators and say that this would be 2/4 minus 1/4. So we would just end up with 1/4, which would be pi over 4. To get the supplement, we would take pi minus my given angle of pi over 4. So this would be 4 pi over 4 minus pi over 4. The supplement would be 3 pi over 4. All right. And then our final example, 3 pi over 2. Okay, well, I can see that 3 pi over 2 is greater than pi over 2. That means that 3 pi over 2 does not have a complement. I can actually also see that 3 pi over 2 is greater than pi. That means 3 pi over 2 does not have a supplement either. There is not another positive angle that could add to pi over 2 or add to pi with 3 pi over 2. All right. Our next idea is arc length. Arc length just means we want to find a portion of the circumference of a circle. Okay? The circumference is basically the perimeter of a circle. We know this formula, right? You've worked with this a lot before, and probably even back in middle school and then into geometry. The circumference of a circle is 2 pi times the radius. Well, if I just want a portion of that, all I'm going to do is multiply the entire circumference by the fraction that I want. Well, to get the fraction that I want, what I'm going to do is take the degree measure of the angle in question out of the entire circle. Okay? We know that an entire circle has 2 pi radians. So if I'm thinking, for example, right, we've got a circle and here is my angle. My goal is to find this length right here. Right? Here's my angle. So what I'm doing is just saying, well, this angle is just going to give me the fraction of the entire circle that I want. And then we can simplify this quite a bit, right? The 2's would cancel, the pi's would cancel, and what we end up with is this formula, right? All we're left with is r times theta, the radius, times the angle measure, and then we denote arc length with an s. So let's label these parts here. S equals r theta is our formula. So s is the arc length, r is the radius, and theta is the angle measure. And it is important that the angle measure is in radians. Okay, for us to use this formula, the angle measure has to be in radians. So let's take a look at an example problem. Okay, so I'm going to go ahead and jot down our formula. S equals r theta. So what we know in this problem is that the radius is 18. So right off the bat, I have my r value of 18. I want to find the length of the arc. So what we're finding is s, intercepted by a central angle of 210 degrees. So I know my angle as well. But we said that that angle has to be in radians. So I need to convert this 210 to radians first. We talked about doing that in the last section. To convert this to radians, I'm going to multiply by pi over 180. Okay, so we want to simplify as much as possible, right? But technically, we don't even have to do that. If we're just going to plug this into a formula, I could just write this as 210 pi over 180 for the purposes of plugging into our formula. So we can say this is 18 times 210 pi over 180, and we can just plug all of this into the calculator. All right, so let's go ahead and do that here. 18 times 210 pi over 180. So the intercepted arc, if we go to 2 decimal places, would be 65.97 inches, right? So S equals 65.97 inches, all right? The next example, right, deals with finding arc length, but in terms of actual distances on Earth. So the latitude of any location on Earth is the angle formed by the two rays drawn from the center of the Earth to the location in question and to the point of intersection of the meridian for the location with the equator. Okay, so before we go any further, let me give you a visual of what that's saying. Right? What that's saying is latitude, all it is the angle formed here, right? The angle formed from the center of the Earth to the equator, and then the center of the Earth to whatever location we're talking about. That angle is how we find latitude. Okay? Longitude is calculated very similarly, except we're using the prime meridian and finding the angle in this direction. Okay? So if we have two cities that are on the same longitude, which in this example it's saying that they are, right? It's saying Indianapolis is due north of Montgomery. We want to find the distance between these two cities. Well, what we're going to be doing is finding the arc length. Okay, if two cities are due north and south of each other, I can just find the arc length. I can essentially make Earth two-dimensional, right, and find the arc length from here to here. All right. So to do that, what we want to do first is find the difference in these two latitudes, right? The difference in the two latitudes will tell me the angle in between these cities. So if I take 39 degrees, 44 minutes, minus 32 degrees, 23 minutes, I can just do 39 minus 32 to get 7 degrees, and then 44 minus 23 to get 21 minutes. So this would be the angle in between these two cities. Okay? Well, to make calculations a little easier, let's convert this into a decimal. We talked about doing that in the last video. All I would need to do is take 21 times 1 over 60, right? Because there are 60 minutes in each degree. So if I do that, I would end up with 7.35 degrees. Okay, so this angle in question is 7.35 degrees. Okay, well, now what I want to do is turn that into a radian measure. Right? If we're thinking in terms of our formula, S equals R theta, I need my angle to be in radians. Again, we talked about how to do this in the last lecture. We want to take this and multiply by pi over 180. So I get 0.1282817. Right? That's my radian measure here. So what I want to do is say the arc length in question, which is the distance between these two cities, is equal to the radius of the Earth, which we're given, 3,960, times the angle in radians, which we said was 0.1282817. And again, I've mentioned this before, but when we're in an intermediate step, we want to take any calculations out to a few extra decimal places. We don't want to round to what we're rounding to until the final step. Right? So always take out intermediate steps to a few extra decimal places. So if I calculate this, then we get 507.9955. Right? So even rounding that to 2 decimal places would just be 508.00 miles. So my answer here, the distance between these two cities, is 508 miles. Okay, again, this just ended up being an arc length problem, but we had to do a few conversions along the way. All right. Our final idea is the area of a sector. Okay, so a sector of a circle is just like a piece of pie or pizza. To get our formula for the area of a piece of a circle, right, we just want to start with the area of the whole circle, and then the same thing, or we want to do the same thing that we did to find the arc length formula. I just want to multiply the whole area by the fraction that I want. So I'm going to take pi r squared and multiply this by the angle in question over the entire circle. Okay? We know that there are 2 pi radians in an entire circle. So what we're going to do then, all we can do is cancel out the pi's, and then we are left with, I'm going to bring this 2 that's in the denominator out front as a 1/2. So we just have 1/2 r squared theta. Okay, so this formula will let me get the area of any sector of a circle, or like a piece of pizza or a piece of pie. All I need is the radius and the angle measure. Again, that angle measure does need to be in radians for this to work. Okay, so let's finish with a quick example here. Let's say we want to figure out how many square inches of pizza you have eaten if you eat a sector of an 18-inch diameter pizza whose edges form a central angle of 45 degrees. So let's write down our formula here and see what pieces we need. So 1/2 r squared theta. So we need the radius. Well, we're given the diameter. Radius we know is half of the diameter. So if the diameter is 18, the radius is 9. Then we need our angle. Well, we're given our angle in degrees. We need it in radians. So I want to convert 45 times pi over 180. So 45 pi over 180. And again, if we wanted a final answer here, we would reduce this. But since we're just plugging that into a formula, I don't need to worry about reducing it here. So I can just say this is going to be 1/2 times 9 squared times 45 pi over 180. And I can plug that into my calculator. So 1/2 times 9 squared, oops, times 45 pi over 180. And we get 31.81 if we go to 2 decimal places. And let's see, we were talking about inches, so this is area, that would be square inches. Okay, so for these formulas, right, we just need to make sure that we are using the correct pieces, right? Sometimes we may have to do something small, like given a diameter, find a radius, or convert degrees to radians, something like that. Just making sure we have the correct information to plug into our formula. All right, so that is it for this video. The final question is going to pop up asking you what questions you have.